The AC method also works when our leading coefficient is not 1. So that's the next thing we're going to take a look at. When my leading coefficient is not 1, I use the same steps that we used for our example above. Our work's just going to look a little different this time. So for our trinomial, my first step is to check for a GCF. I don't have variables as part of every term. 3, 17, and 10 don't have any common factors other than 1. So we have no GCF here. So I'm going to go ahead and list out my A, which is 3, my B is negative 17, and my C is 10. So our next step is to multiply A by C. So A times C for this problem would be 3 times 10, which is 30. And I'm going to look for factors of 30 that add to negative 17. So 30 would be, since I want negatives, I'm going to work with those negative factors. Negative 1 times negative 30, negative 2 times negative 15, and I can keep going, but I actually have the factors I need right here, negative 2 and negative 15. Those add to negative 17. So what I'm going to do is rewrite my trinomial here, my 3-term thing, as something with 4 terms. So 3x squared minus 2x minus 15x plus 10. I haven't actually changed the problem, I've just rewritten it, because if I were to combine my like terms, I would get back to my original problem. But with these 4 terms now, I can split this up into groups of 2 and factor by grouping. So for this first group, my GCF, my greatest common factor, would be x. If I factor out an x, I'm left with 3x minus 2. For my second group, my GCF would be 5. And I'm actually going to factor out a negative 5 because I know I want that first term in parentheses to be positive. So when I do that, negative 15 divided by negative 5 would be positive 3x minus 2 when I factor negative 5 out of 10. Remember, I want my stuff in parentheses to be the same, so if it's not the same, you need to go back and double check the GCF that you pulled out of each section. Since my stuff in parentheses is the same, I can pull that out as my GCF, and then I write what's left over. So that would be x minus 5. And there is my factored trinomial. And remember, you can always check your solution by distributing back. Let's look at one more of these together. We'll take a look at number 8 here. So if I look, I don't have any GCF that I can pull out. So I'm going to go straight to multiplying A and C. So not 8 times 9 would give me 72. And I want factors of 72 that would add to 18. That's going to be 6 times 12. If you don't see those right off the bat, make a list of your factors. But I want 6 times 12 here. So now I'm going to rewrite this as something with 4 terms. So I've just split up that middle term here. I've rewritten this as 4 terms. And then we factor by grouping. So I'm going to split this up into groups of 2 and look for each GCF. My GCF for this first group would be 2x. That would leave me with 4x plus 3. For the second group, my GCF would be 3, a positive 3, which would leave me with 4x plus 3. My stuff in parentheses is the same, so that's my new common factor, my new greatest common factor. So 4x plus 3 I'll pull out, and I'm left with 2x plus 3. And there's my factored expression.